Okay, so I wanted to make a video going through a few of the homework problems that you've been working on from last week. I'm not going to do all of them. I just picked like 5 or 6 of them out of your book, but they should give you an idea of how to solve everything. So let's see, starting with section 4.2. So page 477, and I'm going to start with number 16. And we're told in exercises 15 to 18, the real number t corresponds to the point P on the unit circle. Evaluate the 6 trigonometric functions of t. So for the first one, for number 16, you're given the point negative 24 over 25 and 7 over 24 over 25. So you have the circle and you're given this point right here, which is negative 24 over 25, 7 over 25. You want to find the 6 trigonometric ratios, but again, we don't need to put any thought into this. This is on the unit circle. So the points on the unit circle are our trig ratios. We know cosine of x, cosine of the angle theta is equal to the x. Sine of theta is equal to the y. Tan of theta is equal to y over x. And then I can find my reciprocal ratios. So in this case, cosine of theta is the x value. So cosine of theta is negative 24 over 25. Sine of theta is the y value. It's 7 over 25. Tangent is y over x. I'll go down here so we have more room. So that's y, 7 over 25 over x, which is negative 24 over 25. Those two cancel, the common 25s, and I'm left with 7 over negative 24, or negative 7 over 24. If I want to find the reciprocal ones, we have secant theta, cosecant theta, and cotangent theta. But these are just reciprocals. Secant's reciprocal of cosine. Cosine's negative 24 over 25, so this is negative 25 over 24. Cosecant is reciprocal of sine, so instead of 7 over 25, it's 25 over 7. Cotangent is the reciprocal of tangent, so it's negative 24 over 7. And again, the point being, I'm not putting much thought into this at all. I'm literally just saying cosine is the x, sine is the y, and I'm done. Keep in mind, that only works on the unit circle. It's actually x over the radius or over the hypotenuse. But for the unit circle, that's 1, so we can just drop it. When we have a triangle, which is the next one we'll do, that is not on the unit circle, we do the same thing. We just have to find that hypotenuse. So next up, where's my list? Here we go. Number 44, which is actually on the next page. But it says sine of t is 3/4. And cosine of t is root 7/4. And it says, given the values for sine and cosine, use reciprocal and quotient identities to find the values of the other trigonometric functions of t. So, I have sine and cosine. I draw a triangle. This is theta, and I don't even need to draw a triangle for this, but I'm going to just so we can see it. Sine of t, or I guess theta, so we'll call this t, is opposite 3 over hypotenuse 4. Cosine is adjacent root 7 over 4, which is matching up so it works. Find tangent. That's opposite over adjacent, so it's 3 over root 7, or when we multiply by root 7 on top and bottom, it's 3 root 7 over 7. And I can get this with the triangle, or if I look at that, tangent is sine over cosine, so it's 3 over 4 over root 7 over 4. The 4's cancel, and I get 3 over root 7, like I did here. Let's see, that's tangent. Secant t. Again, I can use the triangle, but I'm going to deliberately not. Secant is reciprocal of cosine. So cosine is root 7 over 4. This is 4 over root 7. which then becomes 4 root 7 over 7 when I rationalize the denominator. Cosecant of t. Cosecant is the reciprocal of sine. Sine is 3/4, so this is 4/3. Cotangent of t is the reciprocal of tangent. Tangent is 3 over root 7, so this is root 7 over 3. And again, all I'm using is the definitions of the trig ratios, SOHCAHTOA, and then the reciprocals, you just flip those. I'm not doing any complex math. I was actually given all the numbers. I'm just writing out fractions based off of their definitions. Next up, number 50. Given sine is equal to negative 8 over 17. And pi and theta is between pi and 3 pi over 2. Yep, find cosine. Okay, so given this information, find that. And this is a standard type of trig problem, but all we do is draw a triangle. I just need to figure out where to draw it. Sine. I know sine is the y value from the unit circle. All I really care about is its sine, S-I-G-N. In this case, sine is negative. Where is the y value negative? Well, it's negative in this quadrant and this quadrant, below the axis. Now I'm told theta is between pi and 3 pi over 2. Well, let's see. This is pi, this is 3 pi over 2, so theta's in here. Now I see where those overlap. In this case, clearly they overlap in this quadrant. That's where I draw my triangle. Now I use what I'm given. Sine is negative 8 over 17. So the sine is opposite over hypotenuse, y over the hypotenuse. So it's negative 8 over the hypotenuse, 17. To find the cosine, cosine is adjacent over hypotenuse. This over that. I just need to figure out this value. I already know the hypotenuse is 17. To find that, Pythagorean theorem. Negative 8 squared plus b squared, this thing, equals 17 squared. Negative 8 squared is 64, plus b squared, 17 squared is 289. Subtract the 64, b squared is equal to 289 minus 64, which is 225. Square root that, b is equal to 15. So I get 15 over 17. And then the one trick here, that is the trick that I think a lot of people have with their homework. Now that I have the fraction, I'm not done. I have to check the sine, S-I-G-N, of my answer. My triangle's in the third quadrant. Cosine is the x value. X is negative in the third quadrant. So the cosine is negative. The other way to look at this, just draw the sides of this triangle, positive or negative based on the quadrant. Meaning, the side of the triangle is not actually 8, because the side of the triangle has to be a positive number. But since I went down in the third quadrant, I just said it was negative 8. This side of the triangle goes to the left, so it's negative. X is negative there. Now I don't even have to think about it. I just say cosine is adjacent over hypotenuse, negative 15 over 17. And I don't have to worry about thinking about the sine, S-I-G-N, of the sine and cosine. Okay, next up, 70. Secant of t plus 2 pi minus secant of negative t. Solve that. And here is where I was just giving you this, check the time, okay. To see if you could manipulate with different properties, because we're going to do more of this later on, so this was kind of your first taste of it. And there's an idea here. The period of secant is 2 pi. It's the reciprocal of cosine, which also has period 2 pi. So because of that, whatever the secant of t is, the secant of t plus 2 pi is the same. If you think about like a circle or an angle, if this is my angle t, if I add 2 pi to that t, I end up right where I started. they have the same secant value, the same angle, the same triangle. They're coterminal, which means I can just drop that. And this just becomes secant of t. Now, there is a property in your book, and we kind of mentioned it when we went over graphing, but secant is the reciprocal of cosine. Cosine is symmetric with the y-axis, the graph. Basic graph of cosine, just a little bit right there. It's symmetric with the y-axis, which if you remember 171 means it's an even function. If it's an even function, it means f of x equals f of negative x. That's true for cosine, so it's true for the reciprocal secant. All that means is, this negative right here, I can drop. Because they're the same value. The negative doesn't matter. Now I have secant of t minus secant of t, and that's just 0. And that's it. Let's see, 72, cotangent of negative, this is the same type of problem, so we'll just do this. Cotangent of negative 3t minus 3 cotangent of 3t plus pi. Now, cotangent of negative 3t minus 3 cotangent of 3t plus pi. The period of tangent and cotangent is pi, which again, same as the last one, means that the cotangent of 3t plus pi is the same as the cotangent of 3t, because the period is pi. So I can just drop that. Now, cotangent and tangent, it listed in your book. I don't want to take the time because this video is almost getting too long for this. Cotangent is an odd function. All that means is, if you remember 171, f of negative x equals negative f of x. What that means is, this negative out in front, I can pull inside the function. So, if I want, I can take this negative, make it a positive, and bring it inside here. And I get cotangent negative 3t plus 3 cotangent negative 3t. There's 4 of them, 1 here and 3 here. So 4 cotangent negative 3t. And I'm just doing algebraic manipulation using my definitions and properties. If you wanted to, you could also go backwards. I could take the negative on the inside, put it on the outside. And I can rewrite this as negative 4 cotangent 3t. They mean the same thing because cotangent is odd. Either answer is completely fine. This video is already too long, so I'm going to have to make a separate video to go through the 2 applications from the next section that I want to go over, and then I'll upload both videos.